How would creatures the size of buildings survive in the most corrosive atmosphere in our solar system? And if skywhales could exist in Venus's clouds, what would keep them from dissolving in pools of sulfuric acid? Venus, often called Earth's sister planet, but in reality it's more like Earth's evil twin. Its surface is hot enough to melt lead, crushed under pressures that would instantly destroy a nuclear submarine. But venture up about 50 kilometers into its atmosphere, and something remarkable happens. Here, in a layer of Venus's clouds, the pressure and temperature are surprisingly similar to Earth's surface. But there's a catch. These clouds are made of concentrated sulfuric acid, one of the most corrosive substances known to science. Yet it's here, in this seemingly impossible environment, that we might find the most extraordinary possibility: skywhales. You might remember the skywhales of Nimbus, those massive creatures that evolved to float in the atmosphere of a distant gas giant. But Venus isn't a gas giant. It's a rocky planet with an atmosphere made almost entirely of carbon dioxide. So how could building-sized creatures possibly stay afloat here? The answer lies in that same carbon dioxide. Venus's atmosphere is so thick with CO2 that it's actually easier for large creatures to float here than in the atmosphere of a gas giant like Nimbus. Think about it like this. When you fill a balloon with helium on Earth, it floats because helium is lighter than our atmosphere. On Venus, even a balloon filled with Earth's regular air would float because the carbon dioxide atmosphere is so much heavier. But what if Venusian skywhales had an even better trick? Some microbes on Earth produce hydrogen by breaking down sulfur compounds. If a skywhale could do the same, splitting sulfuric acid to extract hydrogen, it would have the lightest gas possible, maximizing lift while recycling the very chemicals that make its home so extreme. While hydrogen might be rare on Venus, these creatures could manufacture their own, turning their harsh environment into an advantage. But staying afloat is just the first challenge. Remember those acid clouds? Any creature living here would need extraordinary protection. Earth gives us a clue about how this might work. In the Rio Tinto River in Spain, microbes thrive in waters nearly as acidic as battery acid. They've evolved special membranes and proteins that protect them from the extreme acidity. Venusian skywhales might have similar adaptations, but taken to the extreme. Their skin could be covered in layers of specialized acid-resistant compounds, perhaps even incorporating the sulfur from their environment into their very biology. But an acid-proof shell alone might not be enough. Instead, Venusian skywhales could recruit an army of microscopic defenders, symbiotic microbes coating their skin, constantly neutralizing the acid droplets before they do any damage. A living bioarmor, evolved to withstand an environment no human-built machine could endure for long. But what would these creatures eat? This is where things get even more interesting. In 2020, scientists detected traces of a gas called phosphine in Venus's atmosphere, the same gas produced by certain bacteria on Earth. While still debated, this hints at the possibility of microbial life already existing in these clouds. If microbes can survive here, they could form the base of an entire aerial food chain, just like the cloud plankton of Nimbus. Venusian skywhales might feed by filtering these microbes from the acid clouds, using specialized organs to extract energy from them, while neutralizing the acid they collect. But there's another source of energy these creatures might tap into: the sun itself. Venus's upper clouds reflect most sunlight, but some penetrates through, creating an eternal orange twilight. A skywhale's vast surface area could absorb this light for warmth, reducing the energy it needs to stay afloat. It might even harbor photosynthetic microbes in its skin, similar to how coral reefs on Earth partner with algae. This brings us to one of the most fascinating aspects of potential Venusian life: the daily survival cycle. During the day, a skywhale might float higher in the clouds, absorbing sunlight and feeding on microbes carried up by warm air currents. At night, it could descend slightly, where the denser atmosphere helps retain heat. But these creatures would face a challenge their Nimbus counterparts never had to deal with. Venus's super-rotating atmosphere. The entire cloud layer circles the planet every 4 Earth days, with winds reaching hurricane speeds. Skywhales would need to be master navigators of these eternal winds, perhaps using them to their advantage to find food or mates while avoiding the most turbulent regions. And if skywhales exist, could they be alone? Smaller creatures, fast-moving predators or drifting scavengers, might share the skies, latching onto their massive hosts or feeding on whatever the acid clouds provide. A true aerial ocean where life never touches solid ground. The existence of skywhales on Venus remains purely hypothetical. We have no proof that any life exists in those acid clouds. But the fact that we can explain how such incredible creatures could potentially survive there tells us something profound about life itself. It reminds us that the boundary between the possible and impossible isn't always where we think it is. As we continue to explore our solar system and beyond, we might find life in places we never expected, adapting to conditions we once thought impossible. Perhaps somewhere in Venus's eternal twilight zone, hidden in the acid clouds, float creatures that would completely change our understanding of what life can be. The real question isn't just whether skywhales could exist on Venus. It's how many other seemingly impossible forms of life might be out there, waiting to be discovered.